Another key concept that you've got to get into your mind if you want to understand meteorology or the way that the weather works is you've got to understand this concept, that the air is like a sponge. Now, what do I mean by that? Well, think about what you know about a sponge. Sponges can soak up water and dump water. Big sponges can hold a lot of water, and small sponges can hold a little bit of water. You can use a sponge to pick up water over here and move it over there. Okay, so you can use sponges that way. Well, let's apply that to our understanding of the atmosphere, and we got to ask ourselves 3 questions to do that. Number 1, when you're understanding the weather and understanding that the air is like a sponge, then what you want to know is these 3 things. Number 1 is how big is your sponge. Number 2 is how full is your sponge. And number 3 is which way is your sponge moving. So, how do we answer those questions with meteorology, with the weather? This is how. The size of the sponge, we call it the temperature. Warm air can hold a lot of water. Cold air can't. That's why you might have heard that Antarctica is a desert. And you think, desert? It's got snow everywhere. It's cold. Right, but desert is defined by the amount of precipitation that happens every year. And there's very little precipitation. There's very little snowfall in Antarctica. Most of the snow there just blows around all year round, or all year long, depending upon the season that you're in. So, cold air, it can actually be too cold to snow, because if the air is too cold, that means the sponge is being really squeezed, and it simply cannot hold enough moisture to be able to form clouds and therefore to form any kind of precipitation in the form of snow. So it's possible for that to happen. So the size of your sponge is indeed the temperature. The warmer the sponge, the more water it can hold. The colder the sponge, then the less water it can hold. So air that's warm holds a lot of water, air that's cold doesn't. Simple as that. All right, question 2, and that is how full is the sponge? Well, if I'm going to fill up that sponge, if I've got a big sponge, but I only have a little bit of water in it, well, I can squeeze all day long and maybe not get any water out at all. I've got to fill up the sponge. Well, to fill up the sponge, we use a term called humidity. Humidity is the word that we use to describe the amount of moisture or the amount of water vapor that's in the air. The warmer the air, the greater the humidity. I live in Alabama. I grew up in Florida. Trust me, I understand heat and humidity very well. Okay? So, that's the idea of how full the sponge is. Now, imagine I have a coffee mug that's filled with water. Okay, and it's completely filled. I would say that that coffee mug is saturated, completely filled. If that coffee mug represented the atmosphere, I would say that it's at 100% humidity. But if I take that same amount of water and dump it into a bathtub, well, there's going to be barely any water in the bathtub at all, even though it's the same amount of water in the cup that I just poured into the bathtub. But because the bathtub is so much bigger, relatively speaking, there's little water in the tub. And that word relatively is the one that we will use. So humidity is the amount of moisture in the air, but relative humidity is the amount of moisture that's in the air based on the temperature. In other words, if I have a warm amount of air, if the air is really warm, then that means my sponge is really big. And if it's really big, then I only have a little bit of water in it. It's not going to represent that high of a humidity. However, if it's cooler and I have the same amount of water in it, I've just shrunk my sponge, made it smaller. Therefore, the amount of water given the size or temperature of the air has gone up. And we would say that the relative humidity is much higher now. So relative humidity is an important number to get because it tells us the amount of moisture given basically how much moisture the air can hold. That is the size of the air, the size of your sponge. So we have the size of the sponge, that's the temperature of the air, and we have how full is the sponge, that's the relative humidity, the amount of moisture given the size, given the temperature of the air. The last thing we want to ask is Which way is the sponge moving? The sponge can be moving along the ground, it can be moving up, it can be moving down. All of those things are going to affect how how weather is going to develop. If we have a sponge that rises up into the air, as they go up in the air, think about any time you've ever traveled into the mountains. You go up in the mountains and the air gets cooler. Well, it gets cooler because you're higher up away from the surface of the earth. And as you're away from most of the surface of the earth, that's how we get the heating. Our air warms up because the sun heats the earth and the earth heats the air. That's the way it works. So up in the mountains, we're only on a little tiny bit of the earth. So it's going to be cooler. We're further away from the main surface of the earth. So it's going to be cooler the further up we go. Now, with that understanding, as that air rises, if we can get our sponge to rise, it's going to cool off. Well, cooling off is going to squeeze that sponge, and as we squeeze the sponge, the water begins to come out of it. So rising air, that actually can produce rain. Where if we have air that's coming down, it's usually cooler up here, so as it comes down, it's going to warm up and it's going to soak up water, but it's, in a sense, the sponge is getting filled, not squeezed, so the water's going into the air. We have evaporation and not the other way around. So rising air is going to produce rainy weather, and descending air is going to produce drier weather. So those terms that we use, really, we talk about air pressure. Low pressure is when the air is lifting off of you, it's going up, and high pressure is when the air is pushing down on you, it's coming back down. So the way the air is moving, low pressure and high pressure also are going to help us to determine what kind of weather is going to be going on. So let's review really quick. The air is a sponge, and just like a sponge, it can hold water a lot or a little. We can squeeze it to get the water out. We can expand it to draw water in, and we can move that sponge around to dump it in different places. Same thing is happening with the air, right? We want to ask the three questions. How big is the sponge? How full is the sponge? And which way is the sponge moving? The size of the sponge is the temperature of the air. The fullness of the sponge is the relative humidity, and which way it's moving has a lot to do with pressure. Low pressure going up, high pressure coming down. Those are the key concepts. Review that over and over again, and as we move forward and talk about cold fronts and warm fronts and hurricanes and tornadoes and hail and lightning and all kinds of things, you will have a great foundation for understanding all of those different concepts of weather. And speaking of weather, I better get out of here because I got some coming in right now.